this video I'm going to talk about how to use Excel for optimizing a linear program and also to perform the sensitivity analysis. So here I'm going to write objective function and I'm going to take this particular formulation to demonstrate, and here I'm going to write decision variables. We have two decision variables here in this formulation, S and D, and I'm going to highlight these particular cells for my reference, and Excel will provide the optimal values of S and D in these particular cells. Now here I'm again going to write S and D, but here I'm going to, and in this cell I'm going to write the coefficient of S and coefficient of D. Now I need to evaluate the objective function for a given value of S and given value of D. For that I have written here Z, and which is equal to 10 times S plus 9 times D. So here if you put any value 4 or let's say 5, you will get the objective function value. Now another way is to use sum product function, which asks to provide two arrays for which the sum product has to be performed, and I have provided these two arrays. So basically it's going to perform the same operation that we did earlier, 10 times multiplied by S plus 9 times multiplied by this quantity, and hit enter. Now I'm going to write constraints. We have 4 constraints. Every constraint has LHS and RHS, and I'm going to write here type of constraint. Now in the LHS side I'm going to write the coefficient of each S and D value. So here the coefficient of S is 7 by 10. So when you have to write in terms of fraction in Excel, you need to first put equal to sign and then write the fraction. So it has provided the simple version of 7 by 10. But if you go to this fraction, this particular option here, and more number format, you can actually change the type of fraction. Okay, so up to 1 digit, 2 digit, 3 digit. So here it's 7 by 10, so I'm going to select this up to 2 digits, hit OK. And LHS is 1, so no need to put equal to because it's a number, simple number. So here 1. Okay, in the next cell I'm going to write 1 by 2. In the next cell I'm going to write 5 by 6. And if it doesn't appear as you want it to appear, make sure that you select the proper type of data using this option. Okay, whether it's percentage, whether it is fraction or something like that. Okay, now in this particular cell I'm going to write 1. In this particular cell I'm going to write 2 by 3. Here I'm going to, just for demonstration, I'm writing 1 by 10, and you can see it shows 0.1. To change it to into fraction, I'm going to use this option fraction, but now it is showing 0. So therefore now I need to go to more number formats. Under fraction, just select the second option, up to 2 digits. So that's why it will show the 2 digits. And now the next one is 1 by 4. Okay, it has appeared automatically. In case, again I'm repeating, if these fractions are not appearing as required, just play with this option. Now in this particular cell I'm going to highlight it again for the reference. Okay, I'm going to use this sum product formula. That means I want to multiply 7 by 10 times the value here plus 1 times whatever the value comes here. So first array, and the second array, and then I'm going to use F4 on my keyboard to lock this or to freeze this B5 and C5 selection, so that I can just drag it. and the formula will get copied. On the right hand side, it's 630, 600, 708, 135, and just for the reference, I'm going to write here LEQ, which is less than equal to. Now to perform the optimization using solver, go to data and choose this option solver. Now it is asking what is the objective function, so I have mentioned this is the objective function. Yes, I want to maximize by changing what variable cells. I want to change these two variable cells. Okay, and then click on add first constraint left hand side, the type of constraint less than equal to, and what is the RHS value 630. Click on add second constraints left hand side value. Okay, what is the constraint type less than or equal to, and the RHS value of the constraint, sorry, this one. Then click on add the third constraints left hand side, its type and RHS value. Click add last constraints LHS value, its type and RHS value of the last constraint. Now click OK. Here select a solving method. Since it's a linear program, I'm going to choose simplex LP and click solve, and it will give you the desired result, optimal result, sorry. And to perform the sensitivity analysis, choose this option sensitivity. Okay, once this dialog box appears, just choose this option sensitivity, make sure it's highlighted, and click OK. Now a new sheet will be created just before this particular sheet, where you will get this type of results. Okay, and these are the sensitivity, this is the sensitivity analysis, which provides different type of sensitivity analysis on this given linear program. What is the shadow price or dual price of each constraint here, and allowable increase and allowable decrease in the objective coefficient. So that's how you use Excel to optimize a linear program and perform the sensitivity analysis.